This is an interesting problem because looks like a lot is happening, but we're gonna use the fact that anytime you see something that almost looks like an identity but is not quite there, I'm gonna show you here what I mean. So we know that sine squared of x is equal to 1 minus cosine squared of x. And we also know that cosine squared of x is equal to 1 minus sine squared of x. Always keep in mind that there's a way to factor 1 minus x squared. That can be factored as 1 plus x times 1 minus x. So sine squared of x is also, right, let me do it, 1 minus cosine squared of x. I can factor this as 1 minus cosine of x times 1 plus cosine of x. So always have that in mind, because if you do that, you'll be able to get 1 minus cosine squared of x, and 1 minus sine squared of x is equal to 1 minus sine of x times 1 minus, plus sine of x. Keep that in mind, because right here we almost have identity. We have plus sine of x, so we have this. In order for us to turn it into this, we need a 1 minus sine of x. Nothing will stop me from doing that, because that's a fraction. So I can go 1 over cosine of x, and I'm simply rewriting the cosine of x divided by 1 plus sine of x. If I'm already at that point, I'm gonna push this fraction into becoming an identity. And how will I accomplish that? By multiplying by 1 minus sine of x. So I'm gonna do 1 minus sine of x divided by 1 minus sine of x. I can multiply a fraction by whatever I want, as long as that is minus sine of x and 1 minus sine of x. I can get a 1 by doing a over a, or x plus 1 over x plus 1. As long as the denominator and the numerator are the same, that is a 1. So this is a 1, and if I multiply anything by 1, I'm absolutely not altering my expression. So this is algebra. Now that I have done that, I'm going to actually do the multiplication. So I'm going to keep the 1 over cosine of x minus, and the numerator is going to end up as cosine of x multiplied by 1 minus sine of x. And down here, if you notice, we have 1 plus sine and 1 minus sine is this. If I multiply those two, I'm going to end up with 1 minus sine squared of x. What was my goal? 1 minus sine squared of x is an identity. This is, once again, just algebra again. If you notice, because that is an identity, now I can focus on turning that 1 minus sine squared of x into a cosine squared. So let me just keep the equal signs. So this will become 1 over cosine of x minus cosine of x times 1 minus sine of x divided by 1 minus sine squared of x, that is cosine squared of x. So that is because of the Pythagorean identity, the 1 minus sine squared of x just became cosine squared of x. So Pythagorean identity. Now we're getting closer. We are gonna be able to cancel cosine with one of the cosines down there. And it's gonna get us closer to the answer we're looking for, which is combining the fractions. So this is 1 over cosine of x minus, and I'm gonna end up with 1 minus sine of x over cosine of x. Once again, simply doing some algebra. Now that I have this, just as I mentioned before, whenever I have a difference that becomes a multiplication or simply one factor, some common denominator is gonna be involved in the process most of the time. So here I'm gonna have this as equal to 1 minus, and don't forget that that minus will affect this entire expression, 1 minus sine of x divided by cosine of x. So once again, that was simply algebra. So if I multiply those, I'm gonna end up with 1 minus 1 plus sine of x divided by cosine of x by using some algebra once again. So if I get to that point, I'll be able to cancel out this one with this one. So if I do that, once again, I'm getting closer because this will be sine of x over cosine of x. Once again, that was just algebra. And now we can simply go for an identity that allows us to turn sine over cosine into tangent. And that is our quotient identity. So this is equal to tangent of x because of the quotient identity. We'll try to retrace the steps that we followed to see if we can make some sense out of